we're looking at in this section is we need to be able to see an equation and picture what the graph looks like. It's a really important skill that will help us be able to check ourselves whenever we're answering questions about functions a little better. If we're creating functions, it helps us to see if what we've got is reasonable or where to start from. So it's really important. Now this should be stuff that you have seen before. I think we do some of it in Math 2. Actually we might do a lot of it in Math 2, but only with quadratics. You probably have seen it a little bit in 3 as well. But you should have seen it before, but if you haven't, just pay attention and we'll get you caught up there. So the first thing is y equals negative f of x. So putting a negative out in front of the function. And so if we put a negative out in front of the function, it's going to reflect f of x over the x-axis. So it flips the graph upside down. Okay. This you've seen a lot, like if you have a quadratic that has a negative in front of the x squared term, you know it's going to be a sad face quadratic, right? It's facing down. This one we see less. If you put a negative into the equation, but you put it in parentheses with the x, the difference here, like this would look like f of x equals negative x squared. This one, if we were doing this with a quadratic, would look like this, negative x squared. There's a difference in that because here the square only goes with the x, but here the square goes with the negative and the x. What is negative x times negative x? It'd be positive x squared, right? So the graphs would be different if we put that negative on the inside of the parentheses instead of on the outside of the parentheses. And sometimes it's different and sometimes it's not. But in this case, when we have that negative on the inside, that reflects f of x over the y-axis. So in this case, f of x would be x squared. If you flip x squared over the y-axis, it still just looks the same. It's still x squared. Okay. If we take any function and we put a plus c on the end, where c is some number here, so we might have plus 7 or plus 25. Or it could be plus a negative number, which would make it minus, like minus 4 or minus 8. That is going to shift f of x up or down c units. So that would look, if we were still dealing with a quadratic, that'd look like this. F of, or let's see, I really should be putting y right there instead. Y equals x, oh, sorry, no parentheses there. Y equals x squared plus 5. That would be a quadratic that had been moved up 5 units. Or if you had, you could have minus 7. Y equals x squared minus 7. That would move the graph down 7. Okay, questions so far? All right, the next one looks almost the same. What's the difference between the third block and the fourth block here? Okay, that c is inside of the parentheses here. So that, if we were talking about a quadratic here, that would look like this, x plus 5 squared, like that. So what this is going to do is this is going to shift f of x right C units, and I'm going to put in parentheses here, in the opposite direction. So what that means is if I put a plus 5 plus is positive, which would be the right direction on that x-axis, but it's going to actually make the graph go to the left 5. If I had x minus 7 squared, that would move it to the right 7. So it's the opposite direction. This sign plus typically is right, but it means to go left here. If you see a minus, that means to go right. Okay. If you look at the next two boxes, they look exactly the same. You got c times f of x and c times f of x. So those look exactly the same. But over here, we have where c is greater than 1 or where c is between 0 and 1. So both of these are going to be vertical expansions. I'm sorry. Both of these are going to be vertical. So it's like we're taking the graph from the y-axis and we're stretching it out or we're squishing it in. The first one is going to be a vertical expansion. Well, got that factor right there. Sometimes instead of expansion, you might hear the word stretch. So that is going to take the graph by the y-axis and stretch it vertically, make it taller and skinnier. However, if you have a smaller number, a number between 0 and 1, so we're talking like 0.2 or 1/2 or 3/5 or 0.07, then any number that falls between 0 and 1, then that is actually going to make the graph squish in, shorter and fatter. So that is called a vertical compression. Or sometimes you might hear the word shrink instead of compression. Okay. So when that number is on the outside of the parentheses, if we're thinking f of x, if we're thinking of a quadratic, that would be like this, 2x squared. And right here we would have something maybe like 0.4x squared for that. So that's what it looks like if we have a c out front. Those are vertical expansions or compressions. However, if you look at the next two blocks here, you see we're still multiplying here because that c is right there next to the x, but the c is on the inside of the parentheses. So this would look like this, y equals 2x squared here, or y equals 0.4x squared. So we're still talking about multiplying, but our number's on the inside of the parentheses instead of the outside. And everything on the inside of the parentheses is kind of backwards from what you would think it should be. So for both of these are going to be expansions and compressions along the x-axis, so they're horizontal. So we're either stretching out a graph this way or we're squishing in a graph this way. So they're both horizontal. However, up here, big numbers, when I say big numbers, I mean anything bigger than 1. Big numbers made the graph expand. Small numbers, between 0 and 1, made the graph compress. That makes sense. Big numbers, bigger, expansion. Small numbers, smaller, compression, right? It's backwards for the horizontal compression, expansions and compressions. So if you have a number like 2 inside of your parentheses, any number that's bigger than 1, this is a horizontal compression. So horizontally, big numbers compress the graph. And if you have numbers between 0 and 1, it's a horizontal expansion. Okay, questions? All right, the very last one, I don't know that you have seen before. Usually students have not seen it before unless Mr. Brown or Coach Wood just really got excited and taught you something new. Taking the absolute value of a function. So we have an absolute value as one of our functions, but this is not what I'm talking about. What I'm talking about here is maybe having something like this, y equals the absolute value of x squared plus 2. So the absolute value bars are taking the absolute value of some other kind of function. So typically, if it's just the absolute value graph, you only have an x on the inside. Or you might have like an x plus 2 or x minus 4 or 4x, but there's no squares, there's no square roots, any of those things. If you have something else on the inside of the function, then what it's going to do is it is going to reflect all negative parts of the graph over the x-axis. Now, I'm going to show you what that looks like here in a second because that's a little hard to understand what it means. I'm going to flip over. If you had Coach Wood, I'm sure you used Desmos, right? If you had Mr. Brown, I don't know if he likes Desmos as much. I don't know if you guys looked at it as much. I love Desmos as well. I don't know that I love it quite as much as Coach Wood, but I do love it too because it is so easy to use whenever you're graphing. So so I'm going to just flip over here so I can show you these graphs. So for example, let's say we had y equals x squared plus 2. Okay, so let's do minus 2 so it looks like I want it to. So y equals x squared minus 2. And so if I just have this graph, that's just a quadratic, it's been moved down to. If I do this, y equals the absolute value of x squared minus 2, look what happens to the graph. Everything right here stays the same, and everything right here stays the same because those are both above the x-axis, they're positive. But anything below the x-axis flips upside down. Okay, so that's what we're talking about here. If we looked at it, it doesn't have to be a quadratic, although that's the one I usually look at the most for making you graph by hand. If I have the square root of x minus, minus 1, plus 1 minus 3. Okay, so we've got this quadratic right here, not quadratic, square root function right here. So if we do the absolute value of this stuff, then notice the graph over here is exactly the same as it was before, but right here it's flipped over the x-axis because it's taking any of those values that were negative and it's making them positive. So that's what it's going to look like. I will probably not make you do one like this by hand. We will do some of those first ones by hand, but we won't be graphing by hand today, so we won't worry about it too much. Okay. Questions so far? All right, so let's sum up just one more thing. So I've already said, but when things are on the inside of the parentheses, they work backwards from the way that they work when they're outside of the parentheses. So when a number is inside the parentheses, f of x plus c or f of cx, the graph will behave in an opposite manner than you think it should. For example, a positive number added to the x will make the graph move in the negative or left direction. Okay, or I guess I should add that this word is a little strange for me to make that all one sentence. This is poor grammar right here, but or at least not the best it could be. So I should have also said if you have a negative number, it'll move to the negative, or if you have a negative number, it'll move to the positive or the right direction. Also, when you have a larger coefficient in front of the x, and when I say larger, I mean that coefficient is greater than 1. If you have a larger number in front of the x, it will result in a horizontal compression. And a smaller coefficient, something between 0 and 1, will result in a horizontal expansion. So everything inside the parentheses is backwards. Everything on the outside of the parentheses behaves like you think it should. So a plus 5 is going to move the graph up 5. A big number will expand the graph. A small number will compress. But on the inside of the parentheses is opposite. Here I just have a picture to kind of help you think about it. And since this is in Word, it will actually let me do what I want to do here. So if you think of this right here, vertical expansion, let me make, so a vertical expansion, it's like you take the graph and grab the y-axis and you stretch it out like that, right? So it makes the graph look taller and skinnier. Of course, the scale would not move with it like it is here. But, whereas a vertical compression is like you take the graph and you squish it shorter. So, a graph that once looked like this now would be shorter and fatter looking. Then you also have, I think I've messed up this. So if you have horizontal expansion, you stretch it out there, here, but you would make the graph, as you stretch it, it makes it look wider. And then if you have a horizontal compression, you would squish the graph, not that, and it would squish the graph in. It actually makes it skinnier seeming. So a lot of times it's difficult to tell just by looking whether something is a horizontal compression or vertical expansion. They look kind of the same. Or it might be hard to tell whether it was a horizontal expansion or a vertical compression because they look kind of the same. But if we have the equation, we can tell the difference in what we've got there. Okay. Questions? Okay. Factors of expansion or compression are something else we need to know. Just like the other stuff, if you have a vertical expansion, vertical expansions are whenever the number that you're dealing with is on the outside. On the outside of the function. So this is like when you've got y equals 2x squared. A vertical expansion or compression is easier. It's just expanded or compressed by that factor of whatever that number is. Just a. Or in this particular case, it'd be 2. However, everything on the inside of the parentheses has to be more complicated. So if I have the a is on the inside of the parentheses, like I see right here, y equals f of a times x, or I could use a c like it was earlier. That would probably been better to be more consistent. So that a right there, that is not our factor of compression or expansion. Instead, we have to do 1 over a, which which is the reciprocal of a. It just flips whatever a was upside down. So for example, if I had y equals 2x squared like this, then my factor of compression would be 1/2. Okay, questions? All right, let's do some examples, because that is where we'll really see if we have questions or not. So for all of these, we are looking, first thing we want to do is look for what the parent graph would be. And so in this very first one, I see that little square right there, and that tells me that this is a quadratic. So the parent graph here is y equals x squared. And so then, once I've figured out what type of graph I'm dealing with, I'm going to look for everything that's different than just y equals x squared. So for this one, I got a +3 that's on the inside, and I've got a -2 that's on the outside of the parentheses. So for this, when I have a +3 on the inside, okay, so if you're adding or subtracting on the inside, if you look back at that chart, that is, oh, that's too far. If you look back at that chart, that's this one right here. You're adding C on the inside of the parentheses. That moves the graph left or right, and it's on the inside of the parentheses, so it goes the opposite direction. So if I have a +3 right here, it's going to move the graph to the left 3. And then for my -2 out here on the end, that number is subtracted from the end of the equation. It's outside of the parentheses. So that's going to move the graph up or down. Everything outside of the parentheses behaves like you think it should. So a negative is going to make the graph go down 2. Okay, questions? All right, let's look at number 2. The parent graph here is y equals x cubed. So we can see right there we've got that little cube that tells us this is a cubic function. The only difference between y equals x cubed and y equals 3x cubed is that 3 right there. That 3 is on the inside of the parentheses. So if I refer back to my table up here, I'm looking for where the C was multiplied and on the inside of the parentheses. So that's right here in these 2 blocks. And I have a 3, which is a number bigger than 1. So that tells me this is a horizontal compression. Okay? So whenever we're multiplying by a number that's on the inside of the parentheses, that tells us that the expansion or compression is horizontal. And big numbers bigger than 1, cause the graph to compress because it's backwards. So horizontal compression by a factor of, and when we're talking about the factor here, everything on the inside of the parentheses has got to be backwards, so it's 1/3. Not just 3. Okay, questions? More about that. All right, for number 3, we've got 5 minus the square root of x plus 3. So let's see, I'm going to get you guys to help me some on this. Parent Andrew, what's our parent function for that? Out of those first, yeah, that's good. Look back over that first page. Which one is this like? Y equals the square root of x. So that's our parent function, that square root function. Good. So we've got to look for everything that's different than that square root. So we've got that plus 3. We've got this 5 out here. We also have this minus. All of those things are different than the square roots. So, Jackson, tell me one thing that has happened to this graph. Okay, so, and I have given you one that's a little tricky. On a square root, there are no parentheses, but if it's under the square root, it's like it's in the parentheses. Not down. If it's inside the parentheses, it's going to be left or right. So it'll be opposite direction, so it'll be left. 3, very good. Okay, so that comes from this plus 3 that we've got right here. This one's a little tricky. Anybody know what the 5 or the minus does? Either one of them. Very good. That negative right here, we want to think of this negative separate from that 5, and that negative in front of that square root reflects the graph over the x-axis. So reflected over the x-axis. So that comes from that green, that negative right there. So the 5, what's that 5 do to the graph? Anybody know? I think these are tricky whenever these look like this. Is the 5 multiplied by the function? It is not, right? So it would probably be easier if it had been written like this. If we had written k of x equals negative square root of x plus 3 plus 5, like that. And that is equivalent to the equation that you have here. We could take that 5 and just move it over to the end right here, and since it's positive 5, it would be a plus 5 on the end. And so I think that makes it a little bit easier to see what happens. Let's see. Does anybody know what that does now that it's over here on the end? What's that plus 5 do? Madeline? It's going to move the graph up 5. So that plus 5, it moves it up 5. Okay. Questions? All right, let's look at 4, our parent graph. Emily, what would be our parent graph for number 4? Very good. The y equals x cubed. So that cubic function is our parent graph. So the differences that we have a minus 4 over here. We also have a 2 that is multiplied by the x to the third. So we got 2 transformations that have happened to this graph. Let's see. Leah, can you tell me one thing that's happened to that graph? Okay, what's that minus 4 do to the graph? Perfect. Down 4. And that comes from that minus 4 that we have there. Raphael, what do you think that 2 does? Good. Expands. Is it going to be vertical or horizontal? Vertical. So it is a vertical And I know it's vertical because it's not in the parentheses. If it was horizontal, it'd be inside of the parentheses. Vertical, and it's expansion on for things on the outside of the parentheses, which this is big numbers, bigger than 1, like we got here, cause expansions. They act like they should. By a factor of, what would the factor be for this, Raphael? 2. All right. So if it's a vertical expansion or compression, it's just whatever number right there. That comes from here. Okay. Any questions so far? All right, number 5. These are weird, kind of, I think. All right, so let's first think what our parent graph is. So, Sydney, regular Sydney, not Sydney Claire. What is the parent graph for this one? Very good. Y equals 1 over x, that rational function. So, instead of a 1, we've got a 3 in the top, and then we also have a plus 2 right here. I do need to tell you, for rational functions, rational functions are a little bit like square roots. They don't have parentheses, but if they did, they would be down here on the bottom. So if something is in the bottom, it's like it's in the parentheses. If it were not, it would look like this, 3 over x plus 2. It'd be over here, not in the denominator. So you could pretend like there's parentheses around that denominator there. Also, I think this is a little bit tricky because that 3 right there, I don't even really know what's happening to that. But would it be okay if I wrote it like this? 3 times 1 over x plus 2. Is that okay? Because if I multiply fractions, right, I would put this over 1, and I'd multiply straight across, and I'd get 3 over x plus 1. So really, it's like you've got that 3 is out front, and you're multiplying the whole thing by 3. So, Patrick, tell me what something that happens to this graph. Very good. Vertical, expansion, by, I'm just going to put by 3, by factor of 3. There. And then, Audrey, what about the plus 2? Very good. Left 2. The fact that it's inside the parentheses tells us left and right. We go opposite direction, so positive. We go to the negative direction, which is left. Okay? Questions there? Okay. Just a few more. All right. Chase, what is our parent for number 6? Very good. And so this time, I do need to point something out here. We've got that minus 4, so that's different. We've got this 1/2, and I'm going to treat that negative separately. Okay? So the negative, treat that separate from the 1/2. Okay? And the negative, Andrew, what's the negative out front do to the graph? Good. So we're going to reflect over the x-axis. So anytime you have a negative number out there, don't think of that as negative 1/2. Think of it as a negative times a 1/2. So the negative and the 1/2 we treat separately. The negative part reflects it over the x-axis. So that happens. Then, Evie, that 1/2, what is it going to do? Yes, very good. Vertical compression by a factor of what, Evie? It'll just be 1/2. Very good. So it's on the outside of the parentheses. It's just whatever number you've got there. And then the last thing that we've got to talk about is that -4. Grace, what's the -4 going to do? Almost. It's left or right, but everything on the inside of the parentheses, which there's not any here, but it's basically on the inside, it goes opposite direction. So you have negative direction, which we're going to go the opposite, which will be positive, which is right here. So we would go right 4 for that. Okay. For 7. Let's see. Michelle, what is our parent function for 7? Very good. And so then when we're looking at that, that means we've got a 1/3 out here. We also have a +5 that we've got to deal with that are different. So the 1/3, let's see, who's not called on? Sophie, what does the 1/3 do to the graph? Perfect. So vertical compression by a factor of 1/3. It's multiplied, it's on the outside. It's a small number, so it compresses. And any vertical compressions are just by whatever number you have there. Very good. And Kason, what's that +5 do? Very good. It's on the outside. Absolute value bars, they act like the parentheses here too. So that +5 is on the outside of the parentheses, and it's going to move up 5. Okay. All right, last one that we're going to do today. Carla, for number 8, what is our parent graph? For number 8, square root. Good. All right, so square root of x. And so that means we've got 2 things we've got to deal with there. We've got a negative out front, and we've got the 0.25 on the inside. So let's see. Jennifer. What does that negative do? Very good. So it's going to be reflected over the x-axis. And we know that because of that negative right there. And then, let's see. Brittany. What about that 0.25? Nope. This one's trickier because we haven't done one like this yet. So that 0.25, is it added or subtracted, or is it multiplied here by the x? It's multiplied because it's right beside it, right? So when it's multiplied, we're going to be talking about expansions or compressions, vertical, horizontal. So if you look back at the chart, and this one's tough because we haven't done one of these yet, and we don't do these as much. Probably didn't do them much in math 2 or 3. So when it's on the inside here, that makes it a horizontal expansion or compression. And then we'll look here at the numbers. If it's bigger than 1, it's compression. If it's between 0 and 1, it's an expansion. So which one of those do we have here, Brittany? Expansion. Good. So we have horizontal, expansion by. Now, whenever we have horizontal expansions and compressions, the factor is backwards. So it's not just by 0.25. In fact, it wouldn't make sense for you to have an expansion by a factor of 0.25, because if you multiply something by 0.25, it makes it smaller, right? So if you have an expansion, you need a number bigger than 1. If you have a compression, you need a number smaller than 1. So for all horizontal expansions or compressions, your factor is 1 over 0.25. But more than likely, that's not the answer that I'm wanting you to give, because a fraction with a decimal in it is really not a very good answer. Also, most of this stuff I'm going to give you without a calculator, because if I do give you a calculator, you just type it in and graph to see what it looks like. I want you to be able to do that part in your head. So you're probably not going to have a calculator. So what I would do for this, because I don't necessarily know how to do that, it's a long way in my head. What is 0.25 as a fraction? 1/4. So I've got 1 over 1/4. How do we divide fractions? Oh, I haven't said it to you guys enough yet. Dividing fractions is easy as pie. Flip the second and multiply. It's my favorite little saying. I say it all the time. If you flip the second and multiply, then you just got fractions. Multiply straight across. You got 4 over 1, which is really just 4. So it's a horizontal expansion by a factor of 4. And really, whenever you're doing that 1 over any fraction, like if I do 1 over 2/3, which that's not related to this problem, but if I did 1 over 2/3, I'd have to do 1 times 3 over 2, which would just be 3 over 2. So anytime you have 1 over that fraction, you're just flipping the fraction there. So I'll just give you 4 here. Okay. All right. Questions on any of those things? Okay. Your homework for tonight comes from your textbook, and you got about 20 minutes if you get started on it. It is going to be from page 143, and you guys are going to do 13 through 25, but do not graph. The book tells you to graph those there, but do not graph them, because we haven't practiced graphing any yet. We're going to look at graphing